Hello, today I will be discussing a simple setup of Open Shortest Path First Network. OSPF uses a link state technology to communicate with all the directed links in the autonomous system or a group of networks sharing a routing strategy under a common administration. It also gives you an idea of the bigger picture of your network topology. Moreover, your router in the OSPF network will calculate the shortest path to each destination. Now, we will start by adding our routers and the source of internet in our GNS3 simulator. In order for us to easily identify each router, we will change its name to Router 1 and Router 2. We need also to change the name of its identity and enable Roamon in the console so that we can access later Router 2 from Router 1. Just type in the console /system identity set name to Router 1. To enable Roamon, use tool Roamon set enabled yes. Now we can close the console and proceed to Router 2. We'll just follow the same process and set its identity to Router 2 and enable its Roamon. We'll be accessing our router via Winbox and look for its neighbor, which is Router 1. We can see that the identity has been changed already and the Roamon has been enabled also. We will add comment on the interfaces. ISP for Ether 1 and OSPF for Ether 2 since this interface is used connecting to Router 2. To allow our private IP address in our network to use public IP address in communicating with internet, we need to masquerade our source NAT going to our interface from our ISP. We will also add a DNS server to streamline the process of connecting to websites and services. In this case, we will be using 8.8.8 or Google DNS. To check if the router has an internet already, we will try to ping 8.8.8. As you can see, there is a response already from it. On the OSPF setup, first is we will add the IP address for the router and the loopback IP address. For the loopback, we will use 1.1.1. For the router IP, we will use 192.168.0.1/24 and we will set the interface to Ether 2. Next, we will create an instance in the routing OSPF instances. We'll just leave the default name, version, and BRF. On the router ID, we will use the loopback IP. We will set the originate default to if installed and redistribute to connected and static. Click apply and OK. We will now create a new OSPF area but will just leave everything as default. Apply, then OK. For the interface template, set the interface to Ether2. Use network 192.168.0.0/24. The network type as broadcast. Then we will set a priority of 255 so that this router will be elected as designated router or DR. We will put a simple authentication for security using your desired authorization key. Then click apply and OK. Since the router 2 is not yet configured, we cannot yet see it in the neighbors. Next is we will be accessing our router 2 via Roamon of router 1. As you can see, the identity has been changed and the Roamon has been enabled already. We will put comment on the Ether2 as OSPF. We will add IP address on the loopback using 1.1.1.2. And for the OSPF interface, we will use 192.168.0.2/24. Click apply, then OK. Now, we will try to check if we can access the internet by trying to ping 8.8.8. Based on the result, we cannot ping it because the OSPF is not yet configured. We will add an instance using 1.1.1.2 as our router ID from our loopback IP. Set the originate default to never and redistribute to connected and static. We'll create an area but leave everything again as default. For the interface template, set the interface to Ether2, a network of 192.168.0.0/24. Set the network type as broadcast, then put a priority of 0 so that this router cannot participate in the election and will be tagged as DR other. Now, we will check if we can see its neighbor. Okay, so here it is. The router 1 is already seen. The router 2 is also tagged as other. We'll try again to ping 8.8.8 if there is a response. As you can see, we already have a ping. On the IP route list, we can see the routes from router 1 using a distance of 110. DAO stands for Dynamic Active OSPF. Same also for router 1. We can see the routes from router 2. The router 1 state is DR. It is also shown in the logs during the neighbor election. Okay, so that concludes everything. Thank you very much for watching.